Hello everyone. Today I'll walk you through my project on customer churn prediction in prediction model in telecom industry. I have used this dataset from Kaggle, and this dataset contains 7,043 rows, which is the data for the customers, and 21 columns. And here churn is our target column. I have also created a table of contents here to show what all is present in my Python notebook. Here I have imported some important libraries like pandas for data manipulation, then numpy for numerical computations, and matplotlib and cbond for visualizing trends and patterns in the data. After importing the necessary libraries, I have loaded the dataset here using the read CSV function from pandas. Then to verify that the data was loaded correctly, I have used the .head function which displays the first 5 rows of the dataset. Now this helps to confirm the structure of the data and check its column and the format. Here churn is the target column. As you can see, the dataset includes some columns like customer ID for unique identifiers, then tenure, monthly charges, and total charges for financial metrics, and the target column churn, which indicates that whether the customer has stayed with us or has left. Then using the shape function to get the number of rows and columns in the data frame. Then I have used customer data info, the info function, to get a concise summary of the dataset. This method provides important details including column name and data types, and the number of non-null values, and memory usage of the dataset. And then on screen we can see that there are 21 columns including features like tenure, monthly charges, and churn. I have used the describe function on the dataset so that it gives me a summary of key statistics such as the mean, median, the standard deviation, the minimum and maximum values, and the quartile values. So before we start modeling, we need to clean the data by removing unnecessary columns, converting the data types, and handling missing values. So I'll take you through each step. First, we have removed the customer ID column here as it's not needed for our prediction model, and this I have done using the drop function, specifying the x is equal to column to indicate it's a column removal. Next, I have checked here the data type of each column using dtypes function to ensure everything is in the correct format. Now for example, here total charges is in the object format, is in the object type, which needs a conversion. So to fix the issue, I have converted the total charges column to a numeric type using the pd to numeric function. The errors arguments ensure that any non-numeric values are turned into NaN. After the conversion, I have checked if there is any missing values using the isNull.sum function, and it can be seen clearly that the column total charges has it contains 11 missing values, which we will need to handle through imputation or removal. Finally, again I have checked the data type of the total charges column to see what is the data type now, and we have found that it is not object, it is float. In this section, I'm going to explain how I have visualized the distribution of categorical features using pie charts in Python. So I have imported the necessary libraries like matplotlib for visualization, and next we select the categorical columns here, like gender, the product category. In this case we are excluding the first and last columns because they might not be the categorical features. And then the layout setup for the charts, we calculated how many rows of pie charts we need based on the number of categorical columns, and then here we set up the figures and axes for plotting the charts. We have created the subplots that adjust the size automatically based on the number of rows. Then the colors, like customizing pie chart appearance, so I have defined the colors for the pie charts here, and also the explode effect to make the segments pop out for some better visual visibility. Then this iteration through each categorical column and to create a pie chart. So here we create a pie chart for each column using axis i.pie. This will show the distribution of each category in the column. And then we have here like fewer categorical columns than number of subplots, so we hide any unused axis, so the layout looks clean and very neat. Finally, we make sure that everything that is displayed is well fit, and the pie charts are compact. So here is the output, like the partner, no and yes, with the percentage of how many are no, how many no churn customers are there, and how many customers are the one who are yes. Then again, which all dependents did not continue, which all dependents continued. Then phone service also, which customers had the phone services, which stayed with the telecom industry, with the company, and which customers had the phone service, had no phone service and did not churn also. Like that, we have got pie charts for all the categorical columns. Very easy and interesting also to view. This code snippet is designed to extract the value counts of categorical features in a more structured and tabular format. So here's the explanation of the code of each part of the code. So we begin by creating an empty data frame table, like table data, with two columns, category and count. These two, category and count, and these columns will hold the categorical values and their corresponding counts. And then we loop through each this iteration. So we loop through each categorical column, and for each column we use the value counts method to get the frequency count of each category. And the reset index here, it is used to convert the result into a data frame where the first column becomes the category name and the second column becomes the count. And once all the data is collected, we sort the result using the table data dot sort function, and we have sorted here by both feature column, that categorical column name, and the categorical column, that is the actual categories. This ensures that the table is neatly organized, and first by feature and second by category within each feature. Then display function, here is the category, then count and its feature. It is more clean and a well organized table. Here I am performing a distribution analysis of the total charges feature in the dataset, which helps visualize the spread and patterns of the values. Let's break down the code and its purpose. So we start by setting up a figure and axis for the subplots. In this case, we have two subplots side by side. I'll show you the figure. The figure is set in to like 13 by 4, and the background color of the figure is set to be light gray. Here the figure and the subplots. Then plotting of the histogram. So on the first subplot, we plot a histogram of the total charges column to visualize the frequency distribution of values. We use the sns.histoplot function from Seaborn library with the magenta color to represent the data here. And in the second subplot, we plot a kernel density estimate, that is KDE, also known as its KDE, to visualize the smooth distribution of total charges, this one. And this function fills the area under the curve with the same magenta color. And we also add a rug plot, that is sns.rugplot function, to show individual data points among the x-axis with each tick representing a data point. And then adding legends, then I've added like a second legend to the second subplot to label the KDE and rug plots. So this helps clarify the visual elements in the second plot also. And then later just adding a simple title to the figure and then displaying the plot. This code visualizes the distribution of churn in the dataset using a pie chart. So the key steps include extracting the churn data with a value counts function, then plotting the pie chart with percentage labels here, and adding a legend and title for the clarity, then enhancing the aesthetics with a circle in the center, giving the chart a donut like appearance, then setting an equal aspect ratio to ensure that chart remains circular. So this results in a clear and visually appealing representation of churn distribution in the dataset. This code here performs a gender based churn proportion analysis by visualizing the proportion of churn, that is yes or no, across different genders. So the summary of the key is like the cross tabulation of gender and churn. This function here, it shows the count of churned versus non-churned customers for each gender, and the table is normalized by dividing each row to the sum of its values, this one. Then a stacked bar chart is plotted using the normalized data showing the proportion of churn for each gender, and annotations are added, like percentages are added to the bars in the chart for clarity and displaying the exact proportion of the churn. So this is the data for the female for churn and non-churn, and this is the data for the male. In this way, further data analysis is done in a visual way for other categorical values as well. For example, churn rate by dependent, gender and billing, then tenure distribution analysis, distribution of charges by churn status, total charges distribution by churn status, then comparing average total charges by churn status and tenure distribution by churn status, monthly charges distribution by churn status and gender, churn distribution by partner status, numerical features correlation analysis, use of the heat map, and outlier detection for total charges here. Then summary statistics of the whole data set is here. And again a proper distribution of churn rates by different categories like gender, contract types, dependents, partner status in a tabular or just a numerical form. Now this code here uses box plots to identify if any outliers are present in the dataset, and we have found that there is no outliers. This code here selects all categorical columns from the customer data by filtering the columns by the objects and object data type, which typically represents the categorical features, and it then displays the first rows of the selected categorical variables to give an overview of the data, and which can be further processed for machine learning tasks. Now fitting the ordinal encoder is this is used, the fit function, and then ordinal encoder function is used on the categorical data to learn the unique values in each column, assigning them an integral label. And encoding the data, it's like it's based on the fitted encoder, and the result is stored in encoded variable where the categorical values are represented by integers. And encoder categories here is used to retrieve the categories, that is the unique values assigned to each categorical feature during the encoding. Further, the data was split into train and test data, and imbalanced data was also handled using the SMOT technique. Starting with machine learning models and prediction. In this project, I have used 10 different machine learning models. This is the starting with the first logistic regression model and decision tree classifier model, then random forest classifier model, k-neighbors, support vector machine, gradient boost, naive Bayes, XG boosting, ANN, and L-Llama. And then to evaluate, I have used this particular code, and I've got the results with all the train score, test score, and F1 score here, resulting in that XG boost and random forest were the best performing models in terms of test accuracy, train accuracy, and F1 score. Also, the use of explainable AI here, that is LIME, was done to see if the customers are non-churners or churners, then what are the main reasons behind it. And it was found that the properties like tenure and contract type and online security played a major role in deciding which customers are going to stay with the company and which customers are going to leave the company.